the derivative and tangent line equations. And if you remember, I said derivative is directly linked to the idea of a tangent line. In fact, it's the tangent at a particular point. Usually when we find slope, remember slope and tangent are the same things. So usually when we find slope, we talk about it as a tangent line until this moment in calculus, we can only find the slope of 2 points. Well, calculus gives us the ability to find the slope at a single point. And that's what we have here is we're now starting to interpret the idea of slope at a single point or the derivative or the calculus of it. And in just the context of having 2 points that are the tangent line. So the tangent line to a graph of a function f at this point, it passes through this point. They want us to find f prime of 5, or the derivative of our function at 5. Okay, so basically all we're doing here is they gave us the tangent line. The tangent line goes through these 2 points, right? So at 5, notice this is where it kind of starts at the point here. So that's our input. Remember, our input is 5 here, and that's kind of what we're focused on through the calculus side of it. And then it's passing through this point right here. So we have some graph. It's just touching the graph at that. So I'll just go ahead and draw it. So we have a graph, and it's touching it at 5. So this would be like 5 on the x-axis. And then it's going through some other point, 1. So it looks like my other point would be down here. But just sort of get your bearings about what the tangent line looks like. It just touches a graph at that one spot, and that gives you the slope, the instantaneous slope at that spot. But in this context, basically, it's just asking for a slope given 2 values. So let me go ahead, and I like labeling things. So notice it's at 5, and we're being asked at 5, so that links together. So this is my x1, y1. This is my x2, y2. It's an x. And then the slope is y2 minus y1 over x2 minus x1. So nothing new here other than the context, other than the symbology. So y2, negative 1, minus y1 is negative 7, over x2 is 1, minus x1 is 5. Notice how easy it is when you label everything. You're just plugging it in. It's real easy to make mistakes on these. A lot of you, I know, like to do it in the head. Be very careful about that. Much better if you write everything down, less likely to make any mistakes. Negative 1 plus 7 over 1 minus 5, and I get 6 over negative 4. 6 over negative. So we are going downhill. It looks like I drew my graph a little bit off. And that's okay. The math doesn't lie. This was just to give you an idea of it. All right. So negative 3 over 2, just to reduce everything. All right. Don't want to do all this work and then have them nail us for not reducing. So I got negative 3 divided by 2. Okay. So that's kind of the structure here. Make sure you label everything and do your best to kind of reference what I was talking about with the vocabulary here. Okay, for this next one, looks like the same type of problem. The function, we are given that g of negative 1 is here. G prime of negative 1 is negative 2, okay? What is the equation of the tangent line at g sub negative 1, basically? All right, so let's see, how would I do this? So we got a function. Well, looking at our answers here, this is y minus y1 equals m times x minus x1. This is called the point slope formula. Point slope formula. They're nice. I don't know if I would have first thought of this. Point slope formula, that means you need a point and you need a slope to find the equation to find an equation, in this case, of a tangent line, okay? And that's kind of what's happening here. All right, so that means this right here is our slope. They're telling us our slope, which is equal to our m, is -2 at this point. Good. At -1. So there we go. We got a point. This is my x1, y1 value. And this is the slope given in that context. So remember, like I've said, the derivative is giving you the instantaneous slope at a point. So this is telling us the slope at -1 is -2. So that's our slope. So all we do is we just plug everything in. They set us up nicely for this. So I'd say y minus y1 is 3 equals our m. Our m is -2. X minus x1 is -1. And that just makes a positive there. So y minus 3 equals -2 times x plus 1. And there we go. See how we're doing on this one. So we got a tangent line to the graph at this point, passes through this point. Find f, and notice it's our first value, so that's just asking for the slope again. Find f prime of -1. Find the slope at this one. So this is at our function at this point, and the tangent goes through this point, and all we're doing is just plugging into that slope equation again.